How can you use number sense to evaluate the size of a product? Think about this question during the lesson. Sue knitted scarves that are 4 feet long for herself and her friends, Joe and Alan. After a month, they compared the lengths of their scarves. Some scarves had stretched and some had shrunk. The results are shown in the chart. How had the lengths of Joe's and Alan's scarves changed?
Think of multiplication as scaling or resizing.
What is the original size of the scarves? What scale factors show how the size of the scarves changed?
All right, so on this point, you want to see what number is the same for Sue, Joe, and Alan. So if you look at these 3 sets, you'll notice that each of them started with 4, which means that the original size of the scarf was probably around 4.
The original size is 4 feet long. One scarf changes by a scale factor of 1 1/2. The other changes by 3/4. Let's look at Alan's scarf. Alan's scarf shrunk. Multiplying a number by a fraction less than 1 results in a product less than the given number. Let's look at Joe's scarf. Which is a correct mathematical sentence for Joe's scarf?
Select your answer.
So if you look at Joe's scarf, you'll see that he's multiplying by a number that's greater than 1 because he has 1 1/2. So we know that his scarf is going to be bigger than that actual number. It's going to be bigger than 4.
Joe's scarf stretched. Multiplying a number by a fraction greater than 1 results in a product greater than the starting number. What pattern do you notice?
So if you're looking at this, we're noticing that we're starting with 4. Sue probably stayed the same. Hers didn't go up or down because it's still 4 feet long. Joe's increased because he's multiplying by a fraction or a mixed number greater than 1. And Alan's is going to shrink because he's multiplying by a number less than 1, which means I can't even get the number 4.
The scarf shrinks in size. And if the scale factor is greater than 1, the scarf increases in size. Now you know how to use number sense to evaluate the size of a product.
Morning, ladies. It is Wednesday, March 25th, and it's our 3rd day of distance learning. We're going to be practicing what we've done before, which is called multiplication scaling. And this is when we're comparing the size of basically our product with 2 factors without multiplying. So we're trying to figure out, looking at this problem, is the product of this going to be greater than, less than, or equal to this over here? And we can do that by just looking and seeing what we're multiplying by, because that's going to determine if the original mixed number or fraction is going to increase, decrease, or stay the same. All right, so let's take a look at number 1. And the first thing that you want to do when you're looking at a problem is you want to identify what is the same on each side. Okay, so once you identify what's the same on each side, then you're going to be able to look and see what's different and if that number is going to help us increase, decrease, or stay the same. So we have these 2 mixed numbers that are the same, okay? So we want to look at this mixed number right here to see what it's going to do to 2 2/3. Is it going to increase it, decrease it, or have it stay the same? So we're taking this mixed number by another mixed number. And we know if we're multiplying 2 whole numbers together, so like we multiply 2 and 3 together, that's automatically going to make our number bigger, Okay, so we already know by even just looking at these two that we're multiplying something that's going to be about 6. Okay, and then these fractions don't really matter as much because you already have that whole number, which increases your fractions. So we already know that this is going to be bigger than this. So we want to eat the bigger fraction or the bigger set. So down here, we want to identify what's the same again. But on this one, we're multiplying by a fraction. Our fraction is 4/5. 4/5 is less than the number 1, okay? And we know in order to even get this number right here, 2 2/3, we would have to multiply by a number that's equal to 1. 4/5 is less than 1, okay? So it's impossible to even get 2 2/3 if you're multiplying by a fraction that's less than 1. So this is actually going to be greater than this. So we want to eat 2 2/3 by itself. Down here, identifying what's the same, which is 4 3/5. And then looking at our fraction, which is 4/4. We know that 4/4 is the same as 1, the 1 whole. So we're taking 4 3/5 times 1. And if we take 4 3/5 and we multiply it by 1, we know it's going to get us the exact same thing, which is 4 3/5. So these two sets are equal. So down below, we're going to be ordering these 4 sets from least to greatest. So the thing that I want to start with is I want to start with what's biggest and work backwards. So we automatically know that in order to make something bigger, we have to probably multiply it by something that's bigger than itself. In each of these sets, this is what is the same. That 3/5 is what's the same. So whatever we're doing to 3/5 is going to determine if it's going to get bigger, smaller, or stay the same. So looking at these, we're multiplying by fractions here, and we're multiplying by numbers that either have a whole number or a mixed number here. So let's start with these two. On this first one, we're only multiplying by 2, and over here we're multiplying by 2 1/4. So automatically, 2 1/4, I would much rather have 2 1/4 cookies than just 2 cookies. So if I'm taking 2 1/4 times 3/5, I automatically know that this is going to be the biggest because I'm multiplying by the biggest number out of all of them. So this is going to be the greatest. I'm going to list this one as number 4 because I'm actually working least to greatest. So this is going to be the last one that's in my set. So if this one is the 4th one, working backwards, 2 times 3/5 is going to come right before that. Okay, so that's going to be the next largest. So between these last two, 3/4 is being multiplied by 3/5, or 3/5 is being multiplied by 3/4. So we're taking this fraction and multiplying it by another fraction. So both are less than 1. So we know that our answer has to be less than 1. Or less than 3/5. And then on this one, we're taking 5/5 times 3/5. 5/5 we know is equal to 1. And we knew this one was going to be less than 1. Okay, so this is less than 1. 1 times 3/5 gives me 1, or 3/5. Something less than 1 times 3/5 is going to give me something less than 3/5. So this one's actually going to be the smallest out of all of them. Next smallest is going to be the 5/5 times 3/5. So today for your lesson, I'm going to assign just 2 things. You're going to have your practice, and then you're also going to have a quick check. All right, so once you complete your assignment for today, please make sure you get that submitted for your participation points for the day. And then also, please make sure if you have not watched the videos from Monday and Tuesday that you're watching those as well. And then go back and make sure that you are completing those assignments on Pearson Realize. If you have time today, get on Prodigy or Freckle or any of those extra sites just for a little extra practice. But check back tomorrow for another lesson and have a great rest of your day.